Let's watch Intel Core Ultra processor explained in 60 seconds.
Here are 4 things to know about Intel Core Ultra processors, codenamed Meteor Lake. First, these processors are the driving force of the AI PC. The new chips feature Intel's first integrated neural processing unit for a range of AI workloads. Second, Core Ultra processors are the first PC chips built on Intel 4 process technology. Their tiled architecture features multiple chips built with different flavors of silicon, connected by Intel's advanced packaging technology called Foveros. Third, Core Ultra processors are the most power-efficient Intel's ever built. They contain 2 kinds of cores. P-cores tackle high-performance tasks. E-cores quickly handle mundane jobs with little power, stretching your battery life by hours. Finally, built-in Intel Arc graphics boost 3D graphics performance for smoother, more power-efficient gaming. Intel Core Ultra processors will lay the foundation for PC innovation for years to come.
I'm sure.
Technology called
Intel user. Explorer. Ultra. Oh, let's watch this. Unlock the extraordinary, the Intel Core Ultra 200V series.
Building a great PC is not done overnight. It takes time to refine the technology, optimize the architecture, and deliver a product which is flexible and performant. Every year, we have innovated our chips to make them more powerful, more efficient, more intelligent, to create our most innovative processor yet. Introducing the latest Intel Core Ultra 200V series processor, with all the PC features you know and love, and the AI capabilities that will revolutionize the way you use your computer. Intel Core Ultra features revolutionary core performance, breakthrough power efficiency, extraordinary graphics performance, and incredible AI capabilities. When it comes to performance, Intel Core Ultra delivers the fastest core performance in any thin and light laptop. Built on our innovative performance hybrid architecture, Intel Core Ultra delivers its most powerful performance and efficient cores yet, enabling you to do all the things you're used to doing with your PC more quickly and more efficiently than ever. By placing memory on package for the first time, Intel Core Ultra reduces the distance for complex signals and operations, ensuring the same performance per thread at half the power, so you can finish what you need to do without worrying about an extra charge. With Intel Core Ultra 200V series processors, every stage in the graphics pipeline has been improved and optimized, from generating triangles to shading to the final rendering, enabling 1.5 better graphics compared to our previous generation. Gaming has never been this powerful on built-in graphics. And finally, the NPU has been equipped with 48 TOPS to ensure significant sustained AI performance. And with a combined 120 TOPS of AI performance, Intel Core Ultra 200V series is the most capable AI PC processor. But it doesn't stop there. We are shipping 80 plus Intel Core Ultra Series 2 designs in 30 global retailers. And with over 500 models enabled by 2025, we are enabling the most extensive AI experience possible with a PC.
So these software are the enable the most extensive AI experience possible with PC. So these software might be upgraded for Intel Core Ultra series. I see. Maybe for some color grading or audio adjusting and face tracking things, and also writing I think that these kind of things. Oh, also OBS is also in there.
AI experience possible with a PC. Intel Core Ultra 200V series processor. More powerful, efficient, and intelligent than ever before. Are you ready to unlock the extraordinary?
Okay.
Memory on pack.
Right. I got it. Not sure how it is used. Like NPU, right? NPU. NPU review. And this month. Software, LPU software. Let's watch this.
This video is sponsored by Skillshare. If you've seen what feels like any tech announcement lately, you're probably already sick and
This video is, do we really need NPUs now? I'm not sure
tired
it's
of hearing
all
about on-device AI.
Apple Intelligence.
Personal intelligence right where you...
And it turns out it's a bit of both.
Let's skip
Of parameters basically all at once. This is why Copilot
Copilot
Plus
things.
PCs require at least 16 gigs of RAM, and why iPhones with less than 8 gigs of RAM won't be eligible for Apple Intelligence at all. The amount of RAM directly impacts how smart of a model you can use on any given machine. Third, the NPU also needs its own ultra-fast cache to store the results of its billions of small calculations without having to talk to the main system RAM each time. And fourth, we can speed up these calculations. Allocating a lot of it to the NPU is a real trade-off.
You guys are always pushing us to give you more. You're always saying, more tops, Lisa, more tops.
That was AMD's CEO, Lisa Su, implying that Microsoft really pushed them to prioritize the NPU over adding something else like more CPU cores, for example. So to sum things up, we can see two pretty clear decisions made by the industry so far. First, while NPUs are growing in importance, they are still relatively minor parts of our chips. And second, they are clearly a higher priority in smaller devices and a lower priority in the bigger ones. There is a direct correlation with size, and this holds true beyond just the 4 Apple chips that we've looked at too. NPUs have been common in smartphones since 2017 already, for 7 years now, and they can be found in loads of modern smartwatches and even in chips powering tiny devices like the Meta Ray-Bans. Meanwhile, in PCs, they are just now starting to roll out. That's a pretty clear correlation, and now to understand why NPUs actually matter, let's take a look at the concept of accelerators. Your computer is a math machine. All it does is calculate things. Every pixel, every sound wave, every character of text at the end of the day is represented by your computer as a series of numbers, which it then does maths on. In the early days, all of this math was done on the CPU, a single general-purpose math machine. CPUs are built to be super precise and also flexible, so they can do any type of calculation that your computer could need, including really complex logic using huge numbers, etc. But computer scientists have pretty quickly realized that many calculations simply don't need this amount of flexibility or precision. Take graphics, for example. On a 4K display, you have roughly 8 million pixels, and you'd want to refresh these at least 60 times a second. That is around 500 million updates per second. Now, the math for calculating each and every pixel is super simple, but doing it 500 million times every second is quite the challenge. And this math is exactly what GPUs or graphics processing units are good at, with the best ones currently having over 10,000 compute units. These are much simpler than the big cores of your CPU, but they're designed to run in parallel so they can do a ton of small calculations very quickly. Beside GPUs, there's also tons of other accelerators, such as video encoders and decoders or image signal processors built into every phone to handle the math needed to make your cameras work, etc. The idea here is pretty simple. If a calculation has to be performed again and again and again, it might be more efficient to just build a brand new chip for it that is dedicated to this calculation than to have your CPU do it. And that brings us to the newest accelerator on the block, the NPU, an accelerator built to run the math behind neural networks. Neural networks have for years now been used, especially on mobile devices, to power everything from autocomplete on your keyboard to detecting which parts of an image count as background to be blurred in portrait mode, but also for detecting faces in Snapchat so filters can be drawn on them, or for powering more accurate and faster voice dictation, or for turning sensor readings into useful information like, step counts or heart rates or crash detection, etc. Tim Cook, for example, has claimed that around 200 different models are running on the iPhone already today. To be clear, the vast majority of that actually predates the current generative AI hype, and while many marketing departments would now like you to believe that neural networks are somehow magic, the good news is that they're actually just math. Or depending on how you see things, that might actually be the bad news, because we're now going to have to do a little bit of math together. And I promise you, I kept everything as simple as possible. I even made a little neural network just for us. So welcome to the dumbest neural network possible. This is Martin's image recognition machine. Let's just call it MIM. Okay, so the point of this network is that you can feed it an image that consists of exactly 4 black and white pixels, and the network can then tell you if this image has a diagonal line either this way or that way. That's it. It's the tiniest, most primitive cousin of an image recognition model. The model consists of so-called neurons, which are really just memory cells that hold a number, and then these are arranged into layers, which are then connected. And these connections all have specific numbers called weight associated with them, which I'll explain in a little bit. So in our 4x4 image, let's assign a value to each pixel, 1 if it is white and 0 if it is black. This way we can express any of our images with just 4 numbers. We can take these 4 numbers and then input them into the first layer of our model, which we'll call the input layer for very obvious reasons. That's right, we've now given the model our image as an input. Meanwhile, the output layer has 2 neurons. I made it so that if the first one is at 1, it means that the image gets recognized as having a diagonal line like this. If the second one is at 1, then the diagonal line should go like this. And if anything else is shown, there is no diagonal line detected. So our 2 output neurons are configured to tell us if the diagonal line goes like this or like this. Hence, image recognition. And the calculation goes like this. Take the first value from layer 1, multiply it by its weight, and add it to the first neuron on layer 2. Then you do the same multiplication and addition if we take the second neuron, and the simple network works. Now, of course, repeat it and so on. All of these features of a model are called parameters, and complex models can have over 1 trillion of them. That's right, over 1 trillion parameters. And figuring out all of the intricacies of these networks is done with a process called training, and that typically happens on some gigantic remote server farm. Once we have a model trained, though, we can start using it, potentially even on our own machines, and that's how we get to NPUs. And because you now know the basic math that this requires, you also know what the requirements for the NPU actually are. The calculation that you've already seen is called a multiply-accumulate calculation, because you first multiply 2 numbers and then you add it to a node. Then you multiply 2 more numbers and you add that to the same node, and so on. You multiply and you accumulate, and that's basically it. In the real world, you might also be simple and repetitive, but we might have to do billions of them a second. So we really want highly specialized hardware with many loaded into memory with its potentially billions of parameters basically all at once. This is why Copilot Plus PCs require at least 16 gigs of RAM, and why iPhones with less than 8 gigs of RAM won't be eligible for Apple Intelligence at all. The amount of RAM directly impacts how smart of a model you can use on any given machine. Third, the NPU also needs its own ultra-fast cache to store the results of its billions of small calculations without having to talk to the main system RAM each time. And fourth, we can speed up these calculations dramatically by accepting lower precision. Precision in this case simply means how much memory a computer allocates to any given number. For example, the more decimals that you want the computer to store for the number, the more memory it will need. Precision costs memory. And because we typically want neural networks to just output some probabilistic guess instead of a highly precise answer anyway, we can kind of get away with lower precision, and that in turn speeds up our calculations massively. And there you have it, the 4 things that NPUs need to be optimized for. They need to be able to do many different calculations in parallel, so many little cores, they need a ton of RAM, they need a ton of cache, and they also need low precision. And if you think that this sounds an awful lot like what we've recently said about GPUs, then you're correct. This is why GPUs are very often used for running AI workloads. Since 2017, many GPUs have even had dedicated AI hardware built in, which NVIDIA, for example, calls tensor cores. A 4090 card has a whopping 512 of these tensor cores dedicated to AI, next to other graphics-focused cores, and by today, even integrated GPUs like the ones found on Intel Lunar Lake have plenty of AI hardware too. In fact, on Lunar Lake, the GPU actually has higher peak AI performance than the much hyped NPU, and an NVIDIA 4090 card absolutely blows any current NPU out of the water in terms of raw AI performance. It is not even close. So in short, your GPU already is your primary AI chip when peak performance is desired. It has dedicated hardware and software for running neural networks. And developers already primarily target GPUs for any workload that needs peak performance from a neural network, like say tasks for video editing. NPUs, on the other hand, are much more about power efficiency than they are about peak performance. The NPU on the Snapdragon X Elite chip, according to Microsoft, consumes less than 5 watts of power even at full load. It is a low-power chip designed to run permanently in the background without having to spin up the main CPU or the GPU.
So NPU is like supporting CPU and GPU might be the good understanding of the general things. CPU, GPU, NPU, and NPU is less energy. Let's see.
This, by the way, explains why NPUs first became popular in mobile devices. On PCs, we've generally optimized for peak performance in the past, while mobile users have always had to prioritize power efficiency, especially given that they run tasks like crash detection, heart rate monitoring, and so on permanently in the background. So really the question for computer makers now is what kind of permanent, efficient neural networking workloads they can have that can run in the background that would really benefit from an NPU. Stuff like image generation or a chatbot running locally is often demoed, but I think this is actually kind of silly. Your GPU could probably run these tasks just as well as your NPU, and I bet that they're only used because they are the only features that regular consumers can actually understand. More compelling is stuff like real-time captioning and translations of audio playing on a computer, or for example Windows Studio effects that can blur the background, isolate your voice, cancel echo, etc. on the fly. You could easily use these for hours and do so on a battery, so using an NPU for them totally makes sense. So that's nice, but I don't think we've seen any real game changers in this category just yet. Instead, the most compelling candidate for an NPU by far was, of course, Recall, a system on Windows that takes screenshots of what you do every few seconds. It runs image recognition and optical character recognition software on each frame, and it creates a searchable database of everything on the fly, all running quietly in the background without absolutely nuking your battery. This is exactly the kind of task that an NPU would be exceptionally good for. Computation-wise, this is the absolute sweet spot for the NPU. It is a pretty complicated math problem, and yet it should happen quietly in the background basically all the time without the user even having to notice it. Now the question, of course, is whether people will at least eventually accept this kind of an intrusive system, or whether developers will at least come up with other tools that will be just as good of a use of an NPU as this. For now, I think the answer to both of those questions is not very clear, and so I also think that the value of the NPU is not overwhelmingly obvious either. Now, I don't know about you, but for me, seeing this wave of generative AI taking over everything has ironically only gotten me to care about creativity and actually what I've been making my thumbnails in recently. And I was watching this fantastic 6-hour Skillshare master to make really good, and the platform is customly they've been neglecting over.
Okay, so what I got is NPU, there's CPU, GPU, and NPU, and CPU and NPU will be supported by NPU, and because of efficiency of energy, and I'm not sure. I got the general things. Alright. Let's watch another video.